Venus, our closest planetary neighbor and often referred to as Earth's sister world, is a planet of fascination and mystery. Similar in size to Earth, but orbiting about 40 million kilometers closer to the Sun, this second planet in our solar system has captivated humanity for centuries, inspiring countless stories, myths, and legends. For generations, it was seen as nothing more than a bright circle near the Sun at dawn and dusk. But in more recent times, our understanding of Venus has deepened dramatically. Beginning during the height of the Cold War, a wave of robotic missions was launched to observe, orbit, and even land on this enigmatic world. Equipped with advanced technology, capable of seeing not only in visible light, but also in infrared, ultraviolet, and radio spectra, these missions have revealed a planet that is astonishingly different from Earth in almost every imaginable way. Venus has always held a special place in the night sky. As the second brightest object after the Moon, and sometimes the closest celestial body to Earth, it has drawn the gaze of stargazers for millennia. Yet, exploring this world has never been easy. Interplanetary travel is a monumental challenge, and during the early days of the space race, it was even more daunting. Between 1961 and 1967, the first 15 missions to Venus were launched, but only 3 achieved their objectives: NASA's Mariners 2 and 5, and the Soviet Union's Venera 4. These early efforts paved the way for groundbreaking achievements, including the first successful atmospheric entries by Venera 4, 5, and 6. Then, in late 1970, the USSR achieved a historic milestone with Venera 7, the first space probe to land on the surface of another planet and transmit data back to Earth. This marked the beginning of a new era in our exploration of Venus. Imagine embarking on a journey with that very spacecraft, descending through the layers of Venus's atmosphere, and finally reaching its surface. As the probe begins its descent, it encounters the upper atmosphere, a thin haze extending from about 250 kilometers above the surface down to 60 kilometers. This layer is deceptively calm, with 99% of the planet's atmosphere lying below it. The descent through this region is relatively smooth, much like passing through Earth's upper atmosphere. But the similarities end there. Venus's atmosphere is a stark contrast to our own, dominated not by nitrogen and oxygen, but by carbon dioxide. While the presence of carbon dioxide at this altitude doesn't significantly affect temperatures, it serves as a chilling preview of what lies beneath. Temperatures here fluctuate dramatically, ranging from -37 degrees Celsius to -143 degrees Celsius, with vast differences between day and night. Yet this is only the beginning of the probe's harrowing journey. As the spacecraft plunges deeper, it reaches the main cloud deck at around 60 kilometers above the surface. This is the thick, dull yellow layer that obscures Venus in visible light, stretching down to about 40 kilometers from the ground. Here, ultraviolet radiation from the Sun breaks apart carbon dioxide molecules, creating carbon monoxide and single oxygen atoms. These atoms react with trace compounds like sulfur dioxide and water vapor, forming the infamous clouds of sulfuric acid that shroud the planet. This region is eerily calm compared to the inferno that awaits below. It's a deceptive tranquility, a brief respite before the true nature of Venus is revealed. The surface of Venus remains hidden beneath this dense cloud cover, invisible to the naked eye. These clouds reflect about 75% of the sunlight that hits the planet, thanks to the highly reflective ice crystals formed from sulfuric acid. This reflectivity is a key reason why Venus shines so brightly in our night sky, outshining all but the moon. But while the clouds appear impenetrable in visible light, modern technology offers a new perspective. Infrared sensors reveal a dramatically different view, cutting through the haze to expose the planet's secrets. Images captured in the infrared spectrum show stark contrasts with bands of light and dark wrapping around Venus's atmosphere. Here, the overwhelming presence of carbon dioxide becomes unmistakable. This gas, a potent greenhouse agent, traps heat from the sun, creating an environment of unimaginable extremes. The surface glows under the intense heat, a testament to the planet's scorching temperatures and suffocating atmosphere. This is Venus, a world that defies expectations and that challenges our understanding of planetary science. From its serene upper atmosphere to its hellish surface, it is a place of stark contrasts and profound mysteries. As we continue to explore this enigmatic neighbor, we uncover not only the secrets of Venus, but also insights into the delicate balance that makes our own planet so unique. The journey to Venus is a journey into the unknown, a testament to humanity's relentless curiosity and our desire to uncover the truths hidden within the cosmos. The dark patches and stripes visible in the atmosphere are the infamous clouds of sulfuric acid, towering high above the much brighter, searingly hot layer of carbon dioxide near the surface. Imagine what it would be like to descend through this hellish environment. As the probe plunges deeper, its outer casing is relentlessly assaulted by sulfuric acid. Winds howl at unimaginable speeds, reaching up to 100 meters per second, 60 times faster than the planet's rotation. These ferocious winds are so powerful that they can circumnavigate Venus in just 4 days. The temperature, already ranging between 25 to 75 degrees Celsius at altitudes of 50 to 55 kilometers, begins to rise sharply, climbing to blistering extremes. The surface air pressure is crushing, 75 to 100 times greater than on Earth. To put it into perspective, it's like having an entire car pressing down on your thumbnail. Yet as the descent continues, even stranger and more surreal conditions emerge. Once the probe passes through the bottom of the sulfuric acid cloud deck, it enters a region of clear air. But this clarity is deceptive. The pressure here is so immense that it begins to alter the behavior of the carbon dioxide in the atmosphere. At this depth, the carbon dioxide becomes so dense that it no longer behaves like a gas. Instead, it transitions into a supercritical fluid, a bizarre state of matter that blends the properties of both liquids and gases. The winds, which roared at breakneck speeds in the upper atmosphere, slow to a crawl here, barely reaching 5 kilometers per hour. Moving through this layer would feel like wading through water with a slow, relentless current dragging you along. But this is no ordinary river. It's a scorching molten flow with temperatures soaring to 464 degrees Celsius, hot enough to melt lead. Modern technology has allowed us to peer deeper into these layers, revealing the extreme conditions that define Venus. A near-infrared image captured by the Galileo satellite at a wavelength of 2.3 micrometers shows the lower atmosphere in vivid detail. The red glowing areas highlight the intense heat, while the darker patches above are the sulfuric acid clouds. The lower atmosphere is a furnace, with distinct layers that vary dramatically in temperature and composition. To further illustrate the complexity of Venus's atmosphere, ultraviolet images reveal subtle variations that visible light cannot capture. These images, taken at wavelengths of 283 and 365 nanometers, show areas where ultraviolet light is absorbed rather than reflected. The exact chemicals responsible for this absorption remain a mystery, a puzzle that continues to baffle scientists. Venus's atmosphere is a realm of unanswered questions, defying easy explanation. One of the most enigmatic features of Venus lies at its poles. In infrared images, massive polar vortexes, each roughly the size of Europe, dominate the landscape. These swirling storms, driven by the planet's 100-meter-per-second winds, are unlike anything seen on Earth. Strangely, each vortex has not one but two central eyes, a phenomenon that scientists still struggle to explain. These vortexes are highly dynamic, changing shape and structure in less than 24 hours, making them nearly impossible to predict or model. They are a testament to the chaotic and unpredictable nature of Venus's atmosphere, a world that constantly challenges our understanding. But what lies beneath this chaotic atmosphere? What did the probe see when it finally touched down on the surface of this infernal world? Emerging from the thick, acidic clouds, the surface of Venus is a desolate, otherworldly landscape. The first images, ever sent from the surface, captured by Soviet landers, reveal a surprisingly clear view. Despite the dense clouds overhead, the air near the ground is relatively transparent, though everything is bathed in a dull, yellowish hue, a result of the acidic atmosphere. The ground is rocky and barren, with hints of ancient lava flows now hardened into flat plains, eroded over eons by the planet's relentless heat and pressure. It's a dry, lifeless wasteland, a stark reminder of the destructive power of a runaway greenhouse effect. Some scientists speculate that Earth could one day suffer a similar fate, billions of years in the future, as the sun's luminosity increases. The probes that capture these images, however, were not built to last. The combination of extreme heat and crushing pressure meant that none survived more than a couple of hours on the surface. Yet in their brief operational window, they provided humanity with its first and only glimpse of Venus's surface in visible light. These images, though decades old, remain invaluable. But there is another way to explore Venus's geography and topography: radar imaging. Unlike infrared or ultraviolet light, radar can penetrate the thick clouds, mapping the surface with remarkable clarity. The Soviet Union pioneered this technique with their later Venera missions in the 1980s, producing maps with resolutions of 1 to 2 kilometers. This effort was later surpassed by NASA's Magellan probe, which unveiled Venus in unprecedented detail, revealing a world of volcanoes, vast plains, and towering mountains hidden beneath its toxic shroud. Venus is a world of extremes, a place where beauty and terror coexist. From its swirling acidic clouds to its scorching rocky surface, it is a planet that defies imagination. Every layer of its atmosphere, every feature of its landscape, tells a story of a world that is both familiar and alien. As we continue to study Venus, we uncover not only its secrets, but also insights into the delicate balance that makes our own planet so unique. It is a reminder of the fragility of life and the power of nature, a testament to the enduring human spirit of exploration and discovery. Venus, our closest companion, remains a world of endless fascination, a beacon in the night sky that continues to inspire and challenge us. Between 1990 and 1994, a groundbreaking mission managed to map approximately 98% of Venus's surface with an impressive resolution of 120 meters. The radar images produced from this data are nothing short of spectacular, revealing a world shaped by colossal volcanic activity, massive craters, and a surface that is geologically young, likely a result of the planet's intense volcanic eruptions and the vast lava flows they produced. A composite image created from data gathered by multiple missions showcases the surface in stunning detail, with volcanoes, valleys, craters, and chasms standing out in sharp relief. The power of radar imaging to cut through Venus's thick clouds and reveal its hidden surface has revolutionized our understanding of the planet. And isn't there something profoundly beautiful about uncovering the secrets of a world that has remained shrouded in mystery for so long? With all we've learned about our nearest planetary neighbor, one might wonder what mysteries remain to be uncovered. The answer is simple. There is still so much we don't know. In recent years, one of the most exciting developments regarding Venus was the potential discovery of phosphine gas in its atmosphere. In 2020, observations from the James Clerk Maxwell Telescope suggested the presence of trace amounts of this gas. Phosphine can be produced through various processes, but one possibility, the one that sparked global excitement, is that it could be a byproduct of microbial life in a low-oxygen environment. The idea of life existing in such a hostile, hellish place was nothing short of astonishing. However, subsequent studies failed to detect phosphine again, and by 2022, NASA had dismissed the initial findings as likely errors. But the story didn't end there. In 2023, new reports emerged, suggesting that phosphine had been detected once more, this time deeper within Venus's atmosphere. This tantalizing discovery raises even more questions, and future missions may finally provide a definitive answer. Could life, even in its simplest form, exist on Venus? The possibility, however slim, is both thrilling and humbling. Beyond the question of phosphine, Venus holds countless other mysteries waiting to be unraveled. Why did Venus and Earth, two planets so similar in size and composition, evolve so differently? Was there ever liquid water on Venus's surface, and if so, what happened to it? What can a more detailed analysis of the planet's atmosphere and surface tell us about its history and the forces that shaped it? These are just a few of the questions that drive our curiosity and fuel our desire to explore. After decades of being overshadowed by missions to Earth's orbit and the outer planets, Venus is finally reclaiming its place in the spotlight. Over the next 10 years, a wave of new missions is set to launch, led by space agencies from the USA, Europe, Russia, China, and India, as well as a private American initiative. These missions aim to delve deeper into Venus's secrets, uncovering new insights and answering some of our most pressing questions. Each mission brings the promise of discovery, the chance to learn more about this enigmatic world that has fascinated humanity for centuries. Venus, the star of the morning and evening, may soon reveal even more of its hidden wonders. Looking back at all we've learned, it's clear that studying Venus through a variety of wavelengths has given us far more than visible light alone ever could. We've peered through kilometers of opaque clouds to map volcanoes and craters, analyzed the chemical composition of its atmosphere and surface, and used infrared imaging to make the invisible visible. Each discovery has brought us closer to understanding why Venus is such an extreme and unforgiving world, and perhaps whether it could harbor even the simplest forms of life. The journey to uncover Venus's secrets is far from over, and every new piece of information brings us closer to solving the mysteries of our closest planetary neighbor. As we continue to explore Venus, we are reminded of the boundless curiosity and determination that drive humanity to reach for the stars. Each mission, each discovery, is a testament to our desire to understand the universe and our place within it. Venus, with its swirling clouds, scorching surface, and hidden beauty, remains a symbol of both the challenges and the wonders that await us in the cosmos. The story of Venus is still being written, and with every new chapter, we come closer to unlocking the secrets of this extraordinary world.